All right, guys, welcome back. We're getting ready to look at the volume of a cube, but before we do that, I kind of wanted to finish up our surface area section. So here we have 7 through 16, just kind of wanted to run through the questions I left you with last time. Number 7 simply asks, what shape would you get if a plane intersected a sphere? Okay, and by plane, I mean a flat surface, right? So what shape would you get if it intersected more than one point, right? Because maybe you set a ball on the ground, it touches at one point, but if you were to slide a sheet of paper straight through the middle of that ball, you would get a circle. All right, that's kind of the answer they're looking for there. The next one, they ask you to solve for a quarter of a sphere when we're talking surface area. So you would just take the formula divided by 4 and you would get pi r squared. So it turns out that the quarter of a sphere as far as surface area is just the surface area of a circle, or the area of a circle, I apologize. Number 9 talks about the base of a hemisphere. We talked about that in the last video. That's actually a circle. Number 10 asks for the formula for the total area of a hemisphere. Remember, hemisphere is half the sphere, okay, as far as the rounded part, the dome part, plus the base. The base is going to have the same radius, and the base is a circle, so we've got pi r squared. So we really got 2 pi r squared plus pi r squared, we get 3 pi r squared, okay? So kind of interesting there, the hemisphere is 3 pi r squared. Number 11, they ask you to find the surface area of a sphere given the radius is 6. So there's the math there, you get 144 pi. Number 12, they ask you to find the surface area of a tent with a diameter of 18. Diameter of 18, so you have to do radius of 9, okay? And it's a hemisphere, so we use our formula for number 10. And plug it in number 12, we get 243 pi. Number 13. 13 has surface area of a sphere in terms of pi, given the radius is 15. This is a little bit bigger number than we normally deal with. But 4 pi r squared, 15 squared is 225, times 4 is 900, so 900 pi. Number 4. They actually give us the surface area is 144 pi, and so I'll kind of jot that one up here real quick so you can see it. So 144 pi equals 4 pi r squared. You divide by 4 pi, and you get 36 equals r squared. So your radius has to be 6. Okay. Number 15. They give us 9 and 12 as far as sides of a right triangle. This is a hemisphere. Works kind of like the original examples. So here's kind of your hemisphere here. They tell us this distance is 9, this distance is 12. Remember, we're talking right triangle, so 9, 12, 15, which means this distance is 15. If we wanted the whole thing, this would be 15. The diameter would be 30. That is the first part of question 15. And the second part asks you for the area of that base, which would be 15 squared times pi, so 225 pi. Number 16, last one that we're looking at, we're talking a box that has a ball inside of it, or a sphere inside of it, and the sphere has a surface area of 196 pi. And so given that the surface area is 196 pi, that tells us the radius of that sphere is 7, which means the sides of the box of that sphere sits inside of is twice that. So the sides of the box are 14, all right? And you could take that and kind of extrapolate from there if they asked you for the volume of the box or the area of the box, something like that. Okay, so second section that we're looking at today, we're looking at 36.2. We're talking about volume of a sphere, and so I want to kind of run down the formulas that we're going to be using today. So first we have circumference and area of a circle. Circumference is 2 pi r, area of a circle is pi r squared. Surface area of a sphere, which we just finished with, is 4 pi r squared, and hemisphere surface area is 3 pi r squared. I put them both here because they both show up in questions, so why not have both? So volume of a sphere, I'm just going to give it to you. All right, the book has you kind of work through it, and you're welcome to do the problems in the book, but I'm going to give it to you. The volume of a sphere is 4 divided by 3, 4/3 pi r cubed. Notice when you get to volume, you're talking cubed, and then the hemisphere is simply going to be half of that. So instead of 4/3, it's 2/3. So 2/3 pi r cubed. Okay, so the two volume ones are both going to have cubed involved. Don't forget that. That helps you to kind of identify the formulas. Surface areas and area in general is going to have squareds, and then obviously circumference is one-dimensional, so it's a single radius. All right. So what I have is I created some examples. We're going to use these formulas. We're going to work these 4 examples. What I didn't do in the last video, I'm going to go ahead and suggest, if you feel comfortable with formulas and kind of manipulating, go ahead and pause the video. You've got 4 questions here, and I'll kind of talk through how to work them. Basically, given the surface area of 4 pi, find the volume. Given a circumference of 14 pi, find the surface area and the volume. Given a volume, find surface area and the radius. And then what radius has a surface area equal to volume? What would the radius be of a sphere whose surface area is identical to its volume, okay? So, if you want to pause and go ahead and work those problems, go ahead. Otherwise, I'm going to go ahead and start talking about them. So, number one, surface area is 4 pi. We would set that equal to the formula for surface area, so 4 pi r squared. Notice 4 pi and pi r squared. That means that r squared equals 1, so r equals 1. Volume formula, 4 over 3 pi r to the third. So 4 over 3 pi times 1 to the third power. 1 times 1 is 1 times 1 is 1. All right? So our answer here is just going to be 4 over 3 pi. Okay? And you can write it as 4 over 3 pi, 4/3 pi, or you can write it as 4 pi over 3. These are the same thing. Okay, so on a test, be able to go back and forth, but I don't really care which one as long as you understand it. Okay, number 2, they've given you the area of a great circle. Remember, a great circle is if you have kind of a cutout of that sphere that goes through the center of the sphere, and that's the biggest circle basically that you could create, and it tells us the circumference of that sphere, or that ball, if you will. And so the circumference is 14 pi, and then remember my formula for circumference is 2 pi r, so I set that equal to 2 pi r, which is going to tell me that my radius is equal to 7, okay? My radius is 7, surface area formula 4 pi r squared, so 4 times pi times 7 squared, so that's 196 pi. Volume, 4 over 3 pi r to the third. Notice I'm writing the formula every time. This is a very, very good practice to get into. All right, I know you've got your formula sheet in front of you, maybe you're Googling what the formulas are, okay? But every time you work a problem, write that formula down so that eventually it sticks. Eventually you don't need to look it up, okay? And it means you can go faster, it means you get better SAT scores and all that good stuff. So, 4/3 pi r cubed, we're gonna plug in 4/3 pi, and then instead of r, I'm gonna put a 7 to the third. So 7 squared is 49, times 7 is 343. 343 divided by 3, now we're getting really interesting here. So 343 divided by 3 is going to be 114 and 1/3. So 114 and 1/3, so we're going to get 4 times 114 and 1/3 pi. And just to kind of round it out for a nice pretty answer, this would be, what, 457 and 1/3 pi. Okay, now you can get a decimal answer if you want. I don't like decimals, so I'm going to go with that. And I'm okay with that. It's up to you if you want the decimal. And you can check your decimal answer with mine to see if they match. Number 3, given the volume. All right, again, they gave us volume, so we set it equal to the formula for volume. Our formula for volume, 4 over 3 pi r to the third. Now, how do we solve that? Let's go ahead and clear some space. I want to show this one really well to make sure that you don't miss it. So I'm going to clear some space over here, and we're going to work this one out nice and big. Not that there's anything special here, but it's just some good algebra to kind of remind yourself to make sure you're good with it. So we take the formula, 4 over 3 pi r to the third, and that is equal to 288 pi. Okay? You do the opposite of 4/3. Basically what you end up doing is you multiply by 3 over 4. And so you get pi r to the third equals 3 over 4 times 288 pi. Okay? So 288 divided by 4, that's going to give me 72. 72 times 3 is going to give me 216. And my pi's are going to cancel. So r to the third power is equal to 216. In your calculator, you're going to do the third root of 216. Okay? What you'll find in the calculator, there should be a button or a symbol that looks kind of like this. Either this one where you can tell it what you want the root to be, or you'll see one that looks like this with the 3, depending on which calculator or which program you're using. Okay? But you're looking for what number times itself 3 times. So like x times x times x equals 216, or r times r times r equals 216. And it turns out that that answer is going to be 6. 6 times 6 is 36. 36 times 6 is 216. So that tells me my radius is 6. Well, if my radius is 6, I'm going to plug that into my surface area formula, 4 pi r squared. So 4 times 36 times pi. So 144 pi. Okay, hopefully everybody's good with that, and that makes sense. What radius do we have to get a magical sphere such that the surface area is equal to the volume? How do you think we even start that problem, right? Like, I gave you nothing. I didn't give you the surface area, I didn't give you the volume, I didn't give you anything. Or did I? What's that? It's an equal sign, right? That's what algebra is designed around, and so that's what we're going to use. We're going to use this formula, so I'll write this one, SA equal to volume, surface area equal to volume. Surface area formula is pi r squared, and that's going to equal to 4 over 3 pi r to the third, okay? What in the world do I do with this? Now here, I'm going to make it look really pretty for you. You're going to really like this, okay? Notice I've got an r squared and an r cubed here. If I divide by r squared, watch how easy this becomes. So cancel over here, most of you okay with that. The rule here is if I have 3 r's up here, so this would be 4 over 3 pi times r over r. 2 of them are going to cancel. So this cancels with this. Can we say that? Are we okay? All right, so 4/3 pi r, right, equals 4 pi. Watch. 4 pi, because that's all that's left on that side, equals 4 over 3 pi times r. Now we need to solve for r, right? I don't like fractions, so the first thing I'm going to do is I'm going to multiply by 3. I'm going to get 12 pi equals 4 pi r. Then I'm going to divide by 4 pi on both sides. And what happens? We get our magic answer, okay? And I want you to check that. Check, if you had a radius of 3, find the surface area and find the volume and verify that with a radius of 3, the surface area of that sphere is going to be equal to the volume of that sphere. Obviously the units would be different. One of them would be inches squared or feet squared or whatever. The other one would be inches cubed or feet cubed, okay? So those are my practice problems. Hopefully you like those. All you're doing is applying the formulas, okay? And so with that in mind, let me give you your assignment. I want you to go to the PDF file. You're going to go to page 531, and you're going to work questions 11 through 18. 11 through 18, it should not take you more than 10 or 15 minutes, okay? After about 15 minutes or so, check back in with me and we'll go over the answers. Thanks, guys.